Where this gets a little unpleasant is the half-angle identities. And if you look on your reference sheet, you don't have these, sort of. If you look at the power-reducing formulas, on your reference sheet, you have power-reducing formulas. So let's consider sine squared, and you don't have to write this down, I just want you to kind of get where you should be able to come up with the half-angle identities from your reference sheet that doesn't actually have the half-angle identities. All right, so for example, if you consider the sine squared of u power-reducing formula, you have that the sine squared of u equals 1 minus the cosine of 2u over 2. Now, if I were to take the square root of both sides here, I'd have the sine of u equal to plus or minus the square root of 1 minus cosine 2u over 2. Now, notice that's very similar to this. So if you can remember the connection that the power-reducing formula is basically the half-angle identity squared and without the 2. Notice how the 2 is missing here? If you can use your reference sheet to make that connection, then you'll be okay. Yes, you're missing the formula from your reference sheet, and that's a great and massive tragedy. But what I'm trying to show you here is how you can adapt. So if you look at the relationship between the power-reducing formula for cosine, you see that it's pretty much the exact same thing. If I take the square root of both sides, I would have cosine equal to positive or negative square root of 1 plus cosine 2 theta, but in the half-angle identity, you would lose that. So you've got a little bit of memorizing you'll have to do. And then for tangent, notice it's, again, the same exact idea. You're just losing the 2's out of the radical. Okay? So you've gone this whole chapter without having to memorize something. Now you have to memorize a little bit of something. Okay? So I'm trying to find the sine of 75. That's equivalent to finding the sine of 150 over 2, which means I'm going to use this formula. So the sine of 150 divided by 2 is equal to, and notice the plus or minus. You have to realize that the sine of 75, all right, well, let me look at my reference sheet. 75 isn't on my reference sheet, but I hope that you'd realize it's in quadrant 1. And in quadrant 1, everything is positive. So I know that my answer is going to be positive. All right, so now I can continue. So it's positive square root of 1 minus the cosine of 150 over 2. And that 150 conveniently is on my reference sheet, so I'm going to use that. So this will become the square root of 1 minus, well, the cosine of 150 would be the x-coordinate, at 150, which is negative radical 3 over 2. And then that's all over 2. And then I simplify. I need a common denominator, so I'll have 2 over 2 plus radical 3 over 2 all over 2. And I can't simplify that any further. In the numerator, I would have the square root of 2 plus radical 3 over 2. And then remember how to divide fractions. You multiply by the reciprocal. So I'm multiplying this by 1/2. So that is the square root of 2 plus radical 3 over, notice the placement of my fraction bar, because in the denominator here, I have 4. But hopefully you still know that the square root of 4 is 2. And that's our answer. And you might want to pause your video to catch all of this before I erase it in order to do part B. For part B, I'm taking the tangent of 7 pi over 12, and that 7 pi over 12 is equivalent to 7 pi over 6 divided by 2. Now, on our notes, we have 3 different formulas for the half angle for tangents. But I want to caution you, use the formula that is closest to what's on your reference sheet. Because remember, you don't have all of these formulas on your reference sheets. You're having to kind of use the power reducing formulas to move and shake it into the half angle identities. So we're going to use that this is equivalent to positive or negative. Well, let's think about that. Pi over 12 is going to be, 7 pi over 12 is going to be in the second quadrant, which means that the tangent is negative. Now, if you don't know how I figured that out, realize 7 pi over 12, it's less than pi, which is 12 pi over 12, but it's greater than half pi, 6 pi over 12, which means 7 pi over 12 is in the second quadrant, making it negative. Okay, so it's going to be negative. And let the ugliness begin. Write small. So we have negative 1 minus the cosine of 7 pi over 6 over 1 plus the cosine of 7 pi over 6. So I have negative square root of 1 minus negative radical 3 over 2 over 1 plus negative radical 3 over 2. So I get a common denominator in my numerator and denominator, and I'm going to rewrite this as negative, big gnarly ugly square root, 2 plus radical 3 over 2 over 2 minus radical 3 over 2. Now I can rewrite that division as multiplication of the reciprocal, so I've got negative 2 plus radical 3 over 2 times 2 over 2 minus radical 3. So when I do this, conveniently, my 2's cancel out, and I've got negative square root 2 plus radical 3 over 2 minus radical 3. Now, for some of you, you might be inclined to rationalize the denominator of this fraction inside of a radical. However, in order to end up with a cleaner answer in the end, I want you to realize that if I multiply top and bottom by 2 minus radical 3, my denominator is now a quantity squared, and my numerator ends up being something very nice and neat. Okay, so let's go through that step by step. In my numerator, when I FOIL this out, I got negative, still in this big square root, 4 minus, now when I do the 2 times negative radical 3, and then the 2 times positive radical 3, those are going to cancel out. And what I'm left with is 4 minus, well, what's radical 3 times radical 3? That's just 3. Over, now I've got this 2 minus radical 3 quantity squared. Now I'm taking the square root of that. So what's the square root of 4 minus 3? Well, 4 minus 3 is 1. So I have negative 1 over 2 minus radical 3. And now that big nasty radical is gone. So all that's left for me to do is now go ahead and rationalize the denominator by multiplying top and bottom by 2 plus radical 3. And again, in my denominator, I end up with 4 minus 3, which is just 1. So I have negative 2 minus radical 3 as my final answer. And I know that was a lot of convoluted algebra, and that's why we're taking a few days to get through this lesson. In example 6, once again, just like how in a previous example we were using the double angle identity to solve an equation, now we're using the half angle identity to solve an equation. So, I'm going to rewrite this using my sort of half angle identity that I sort of have off the reference sheet. So I have 2 times the square root of 1 minus cosine theta over 2 squared, because of this, plus cosine x equals 1 plus sine x. So I have 2 times 1 minus cosine of theta over 2 plus cosine x equals 1 plus sine x. Well, these cancel out. That's convenient. Oh, hey, look at that. These cancel out, leaving me with 1 equals 1 plus sine of x. So sine of x is 0, and I'm looking for a y-coordinate of 0. Where does that happen? That happens at 0 or pi. Once again, you might want to pause your video long enough to copy everything down from this screen, since I have to erase in order to get part B. In part B, since I have 8 tangent x over 2 as a greatest common factor in the 2 terms on the left-hand side, I'm going to factor that out. So I've got 8 tangent x over 2 times the quantity 1 plus cosine x equals 1. Then I replace that tangent of x over 2 with that dreadful radical 1 minus cosine, x over 1 plus cosine x times this 1 plus cosine x equals 1. At this point, probably the only manageable thing that I could do is square the whole equation. So what's going to happen when I square the whole equation. Let's look at everything that is happening in this equation. I've got 8 times that radical times that. So I don't have any weird foiling I need to do here just yet. Okay, so I'll have 64 times 1 minus cosine x over 1 plus cosine x times the quantity 1 plus cosine x squared equals 1. And so now let's look at this. I've got these two things that can cross-reduce, leaving me with (64) times 1 minus cosine x times 1 plus cosine x equals 1. If I were to FOIL out that 1 minus cosine x times 1 plus cosine x, I'd get 64 times 1 minus cosine squared x. Oh, well, that's convenient. Then 64 sine squared of x will equal 1. The sine squared of x would be 1 over 64 when I divide both sides by 64. The sine of x would be positive or negative 1/8. And if you're looking for a y-coordinate of positive or negative 1/8, you'll go blind before you find it on your unit circle. Now we use our scientific calculator to find the values of x such that they are the arc sine of positive or negative 1/8. So in our calculator, if we type in 1 divided by 8 and do the inverse sine of that, we get 7.2 degrees. What you need to realize from having used our unit circle so many times is that on the unit circle, for example, look at the 30 degrees. Notice how its x-coordinate is radical 3 over 2 and its y-coordinate is 1/2. Notice an angle just like it in the second quadrant, 150 degrees. Notice that the x-coordinate has changed signs, but the y has not, which means that the sine of 30 degrees and the sine of 150 degrees is both 1/2. So if I take that into consideration with this angle, 7.2 degrees is an angle, and so, or a value of x, and so is 180 minus 7.2, which is 172.8. Okay, so x equals 7.2, x equals also 172.8, but what else can it equal? Well, what if I type in negative 1/8 and take the inverse sine of that? Well, then I have the opposite angles. But always remember, good grief, this equation is long. Always remember where we came from. This problem didn't start in sine. It started in cosines and tangents. Okay, so even though the solution way down here could be the arc sine of positive or negative 1/8, we need to realize that we got an extraneous solution when we squared both sides of the equation here. So remember from earlier in the chapter that when we square both sides of an equation, and this was true back in Algebra 2 when you were squaring square root equations. When you square both sides of an equation, remember that you run the risk of getting extraneous solutions. Okay, so down here, we need to disregard the arc sine of negative 1/8, and our only two answers are 7.2 or 172.8.